So, when we're dealing with similar figures, the definition of similar figures is
Write this down.
we've got figures that have the same shape, but not necessarily the same size. They're called similar. Usually when we think about similar, we think of things that look the same, but not quite, right? In math, the word similar means same shape, but not the same size. Everybody say same shape.
Same shape,
But not the same size.
not the same size.
Good, so these two triangles are similar. Why?
But they're the same shape, but not the same
Exactly.
size.
ABC is smaller than EDF. They have the same shape, but not the same size. One of the ways that we identify similar figures is by what's called corresponding angles and corresponding sides. Everybody say corresponding angles. Everybody say corresponding sides. Good. Corresponding angles are angles that are in the same location. Not in the same location with regards to everything else, but on the shape. So angle B and angle E are in the same location on the shape. If this triangle was spun, like if it was sideways, angle B and angle E would still be corresponding, because they're in the same location with regards to everything else. Side AC, everybody say side AC, is corresponding to which side? DF. Not because they're both on the bottom, but because they're both that specific length. They're across from this angle mark. Okay? So, we've got this shape. Now you also have these triangles. I'm telling you right now, these triangles are similar. I want to find their corresponding angles. So, can you guys name their corresponding angles? The angles that are in the same location for these two triangles. Allie. Good. Say it again. L and E. Notice how I'm labeling them. You guys see what I'm labeling them with? What does that kind of look like? What's that kind of look like? That is called an angle symbol. So you put a little angle symbol in front of angles to note that it's an angle. It's called notation, okay? What's another one? Roman?
F and M.
Angle F and angle M. Notice how we say that. We say angle F and angle M. We use the angle symbol before we use the word angle. Who can give us our last one using the correct terminology now that I'm giving you more? Yeah, Bossum?
Angle G and angle M.
Good. Well said. The other people weren't wrong. I hadn't told you yet.
Does it matter if they're capital or lowercase?
It does. Lowercase letters are variables. Capital letters, in this case, stand for angles. Capital letters are angles. Now let's name our corresponding sides. Okay? Corresponding sides. We name sides using two letters. We name sides using their endpoints. Anybody got an idea of how we could name one set of corresponding sides? If you're wrong, I don't care. We can always adjust. Yeah, Roman?
Angle, E, and L.
Say it again.
Angle, E, and L.
Well, we actually already have that over here. We're looking for corresponding sides this time. So we name the sides by their endpoints. Ashley, you want to give it a try?
Angle, E, F, and angle, L, M.
Good. And I love that you're saying the word angle. That's awesome. But we actually want to say side. So say it one more time with the word side.
Side, E, F, side, L, M.
And side what?
L, M. That's
L, M. Good. Notice what I put over these? Those mean segments. So we would say segment EF or segment LM, or you could say side EF and side LM. That's the notation for sides on a shape. Okay? Give me another one. Yeah, Allie?
Side MN and side FG.
Yeah, and FG. Those are the two bottom ones, right? MN and FG. They're corresponding, they're in the same location. And the last one? Peyton? Hines? Which side hasn't been said yet?
side, E, G, and side, L, M.
Perfect. And side LN. The diagonal side hadn't been said yet, right? They're the sides that are corresponding. They're the ones that match up. EF and LN, we would say those are the two shortest sides, right? MN and FG, we would say that those two would be the medium sides. EG and LN, those would be the two longest sides. They match up. They're corresponding. They're in the same location. Okay? We'll give you guys a chance to get some quadrilaterals, or to get some corresponding parts. You and your partner are going to name the corresponding angles and name the corresponding sides on these quadrilaterals. How many pairs of angles should you have for these quadrilaterals? How many pairs should you have? There should be 4 pairs. Why? There's 4 angles. How many pairs of corresponding sides should you have? Why? There's 4 sides. Cool. I'll give you about a minute to a minute and a half. Talk about it with your partner. Yes, that's actually what I mean is use words and converse with your partner. Use words to converse with your partner. Talk about it with them.
And pair means 2.
Get those angles named. We're writing as pairs. So let's start naming. We haven't even gotten to the math part of this. Right now we're just doing the identifying part. Now careful. How many letters should the sides have? How many letters should each side have? 2. We name those sides by their endpoints. Okay? They should all be capitals. Okay? They should all be capitals. Lowercase letters are variables.
These guys are both in the
Capitals correspond to points. Talk to your neighbor, please. There's nobody talking. Let's go. Talk to your neighbor. Make sure you agree. We should be getting sides written down now. We should be on to the sides by now. Keep in mind what corresponding means. Corresponding means just matching up. They match with each other. They should put segment bars, a little bar over the segment names. We don't put them over the angle names. We put little angle symbols in front of the angles. Make sure you copy the method that I've done. Angle symbols go in front of the angles. And segment bars go on top of the segments.
So you want to know about G?
Segment bars. That should have been hopefully enough time to get most of it done. Check with me. Notice J and W are in the same location. Now, what if this shape was spun? Well, we'd have to then have some benchmarks, some places to look at. Specifically, M and Z, they're a little bit helpful because they're like the pointy piece, right? Or the pointy piece. Or ML and ZY, right? This one, ML, LM, and YZ. They're the longest sides, so they would be corresponding. The shortest sides would be JK and WX. You can tell them by just looking at them being the shortest. So if they were spun, there are other ways that you can identify, these corresponding sides. So this is just practicing identifying corresponding angles and corresponding sides. Now, there are other ways to name angles, but we're just going to stick with this way. Let's flip over to the next part. If we know that things are similar, that 2 shapes are similar, this is the key. This is the biggest thing that we're going to learn today. If we know that a triangle is similar to another one, then we know that the corresponding side lengths are what? What's it say? Are proportional. Hey, remember when we did all that proportion stuff? They're proportional. And corresponding angles have the same measure. We're going to focus a big time on our notes. In our notes, we're going to focus on this part. Corresponding side lengths are proportional. So this guy. It's a big one. So you'll notice AB and DE, are they on the same shape?
No.
No, but what are they? They're corresponding, they're in the same locations. What about BC and EF? They're corresponding, which means they're in the same locations but on the different shapes, right? AC and DF, same deal. And then of course the angles that are corresponding, they have the same measure. That's a little bit easier to work with. So this is just a definition. This is actually what are called the two properties of similarity. The first one, corresponding side lengths are proportional, which means what can we do with them? What's that look like? Oh, then we can set up a what? A proportion. So we can solve for missing sides using a proportion. So that's kind of nice. All right? So one thing that I want you to notice is this phrase right here. It's freaking out. There we go. This phrase right here. These two mean the same thing. These two things. Triangle ABC is similar to triangle DEF. This is how you say it with symbols. This little squiggle means is similar to. Everybody say is similar to. Good. So this phrase right here and this phrase, they're the same thing. This is it written in English, this is it written in math. Okay? So what we're going to do is we're going to actually just solve for some missing pieces. If you know that two figures are similar, then you can use proportions to solve for missing values. What we're going to set up a ratio that matches corresponding parts to each other. So we have example 1. Let's see if my pad's working. Hey, it's working.
Must needed recharge.
Exactly. Must have just needed some help. So what we want to do is we want to set up the two triangles. We want to set up a proportion. My advice is to pick a way to compare them. For this one, I'm going to compare the little to the big. So I'm going to do little over big. Did you guys notice that on here, on this one, AB, BC, and AC, where do they all come from?
Little over big.
They came from the little one. DE, EF, and DF, they all came from the big one. You don't have to do little over big, I just find it's helpful to do that. So what we can do is we can set up a ratio to compare them. Do we see the sides that are going to be the most helpful?
Yes.
Which two sides are going to be the most helpful?
B, A, and F, and D.
Yeah, BA and FD. Why? Why is that helpful? Because we're given two numbers, and these two sides are what?
Corresponding.
They're corresponding, which means that they can be proportional to the other sides. So we have 8 over 20 is going to be equal to what? Is it going to be x over 6 or 6 over x?
X over 6.
Why is it got to be x over 6?
Because we did little over big.
Because we chose to do little over big. Could we have done big over little? Yeah, it would have just been 20 over 8 equals 6 over x. The key is just making that choice, deciding. So I did little over big, and now we can solve this. How do you want to solve it?
Multiplication.
Let's use cross multiplication. Okay. So we've got 20x equals 8 times 6, which is 48. Divide both sides by 20. And we get that x equals 20 goes into this 2 times 2.4. And there are no units for this particular one because, well, I didn't give you any units. So why was this helpful? Well, you were told that these two are similar, and that's going to be really important for us. If we're told they're similar, that means the sides are proportional. Right? That's part of the properties. Sides are proportional, which means that 8 and x are proportional to 20 and 6. Coolio? Let's do another one. These two pentagons are similar. What does that mean for us?
That they're corresponding.
That corresponding sides are?
The same.
Yeah, so we have corresponding. They're not the same.
They're similar.
Nope. What's the word up at the top? I circled it with yellow. You probably should have circled it as well. Are proportional. Corresponding sides are proportional. I just want you to say it loud. Do you want to do little over big? Let's do big over little this time. Let's switch it up. Let's do big over little. All right? Which sides are going to be really helpful for us? Which ones? 10 and 8, yeah. 10 and 8. Let's do 10 over 8, because we're doing big over little this time. Why not, right? Which sides do we now need? Which ones should we set these proportional to?
6 and X.
Why not this 7 or this 9?
Because we're solving for X.
We're solving for X, so we need to get a corresponding side with X. So notice the X is on the bottom there, so 6 is on the bottom. So then is it going to be X over 6 or 6 over X?
6 over
Why?
X.
We did big over little this time. Now, which of these is not helpful?
7 and 9.
Yeah, the 7 and this unknown value, and this 9 and this unknown value. Why are those not helpful?
Because you don't know.
You don't need to know them. Because they don't matter.
We don't know 2 of them. The 10 and the 8 were helpful because we know both of them, right? We can set up a full fraction. The 9 and this unknown value, we would then know, then there'd be 2 unknown values, and we don't want that, right? So not helpful. Let's cross multiply and solve. Luckily, we've already done 10 and 6, haven't we? Or 8 and 6, haven't we? 48 equals 10x. Dividing by 10 is pretty easy, right?
Yeah.
So x equals what?
4.8.
4.8. So, we needed to know shapes before we did similarity because we needed to be able to find corresponding parts. Tomorrow we're going to be finding areas using similar figures. Today we're not. Today we're just going to be practicing solving for a missing side. Questions on this? We have one more piece of information to get before you go. It's just an extension of this though. Indirect measurement. It's how we measure something that's difficult to measure. All right, so in this case, the problem is asking me you've got a person that is standing 12 feet from a street light. He casts a shadow as shown. He casts a 3-foot shadow. He also stands 12 feet from that street lamp. It's 12 feet. All right? Assume the triangles are similar, which is nice. It tells us that if they're similar, then corresponding sides are proportional. So what we can do is we can set up a proportion. What is the ratio? That's going to be important. We're not actually solving for missing side. We're finding a ratio. That's a fraction. Ratio of the height of the person to the height of the street light. So what we're going to do is we're going to set up a ratio. Person to street light. All right, person to light. I don't know. Can you guys see that? I don't know. I'll trace it so it's a little bit easier to see. So person to light. So person to street light. Person to street light. There we go. A little bit easier to see. So that's what we need to find. We need to find a relationship there. So let's start off with our person. Person's a little bit easier. We can trace him. I made him green. So there's my person. 5 feet by 3 feet. Okay, cool. So I have some lengths for the person. Now I need to get the street light. All right. So here's my dilemma. I don't have any of these lengths. I don't know the height of the street lamp, so I don't know that. Here's my lamp. But I do know the bottom length. That bottom length is 12 plus 3. So 12 plus 3 is 15. So now I can set up my proportion. Person compared to light. So my person is 5 to x, right, because these two are corresponding. They're in the same location. Should be equal to 3 over 15. Well, because those are in the same location. Which actually that leads me to my ratio. That tells me that my ratio, comparing the two, is going to be 3 over 15. What does that simplify to? 1/5. Good. So 1/5 is my relationship. So the height of the person is 1/5 the height of the street lamp.